Good morning, everybody. How's everybody doing? It's the first day of February, and I spent the night setting up the studio. Yeah, try some different music. Try some different music. It seems, who do we got? We got 6 people watching. Cheers out to you. But in the chat, I get just a few people. Don't be shy. If you can chat, join the chat. You can all tell me how I'm doing everything wrong uh, as I'm doing it. Yes, Rocky is here. And let's see if I got this right. Oh, look. You can see what the studio looks like. I got another. Hey, good morning, Pete. Good morning, Pete. So, yeah, away from you in the down corner and up there at that other camera. Let's see, what else do we got going on here? I can now switch camera views using my hey and Todd Armstrong and JP down in Riverside, California. Good morning to you. Let's see. Yep. So let's go back to the main camera. Yeah, it's a lot easier now that I've got hotkeys set up. And now I can see myself everywhere. I got StreamYard over here on this monitor, and I've got OBS over here. And I got a mic on, and oh my God. Where's my producer? Where's my makeup person? We got a real show going here now. All right, yeah. Let's go back around the horn. Oh, yeah. Let's put that on the desktop, and there we go. I can share my desktop. Isn't that nifty? Yep, this is the decoder that we're going to be showing today. So let's go back to one. And yeah, and I need to go back over here to StreamYard. Hey, Kyle, welcome to the show. Sorry for your experience with scale trains. I've got 2 that are inbound to me. GP30s, 2 GP30s are coming in sometime. I don't know when. I thought they were going to be here yesterday, but maybe today. Okay. We got 10 people watching. Mom might be out there. She said she would be. Hi, Mom. And want to get into the show here. But let's first go around the horn. Anybody got any updates I want to share? I saw Dwight put out a good layout update maybe last night or early today. So he's got some work ahead of him with putting that turnout in. And yeah. So without further ado, I think we'll get into it. I got this thing. I saw these things. I think I first saw this over on Facebook. Let's switch up. Let's see what would be the best one to do. Let's go over here. We're talking about a decoder. So, and this is Proto Design Labs. I think I put the link in the show notes, but it didn't. Protodesignlabs.com. So, when I'm showing my desktop, I can't read even your comments. So there we see everybody's comments. Um, let's see. Let me go back through this. Just 1 second delay here. I'll go back through the comments and see how I catch up on things. JP says I added 16 sections of double main line and my yard into the switching area. Also added 3 number 8 turnouts. Very industrious. More than I get done, but I have been super saturated with work. We've been really busy. Kyle's ordered 2 new coal hoppers and 2 GP9s. Cool. Be interested to see that stuff there. And we got a new person I have not seen. Ricky, good morning from Corsicana, Texas. Howdy to you. Thanks for coming. And Brother Dan has joined us in the chat. Up to 13 people. And Kyle says, I got my scale trains working, just user error. I was hitting the wrong button. Yeah. Sometimes we are our own worst enemies. But sometimes it is the technology. Oh, okay. B&O solid blue scheme. Well, that will almost get Sparky excited because isn't that the scheme almost like the one he likes so much? Oh, Conrail, not CSX, Conrail. There's so many features I get lost on the ESU decoders. I get lost on all my decoders. I really have problems. I really wish I didn't have so many different decoders. This is the problem. Okay, Pete says, I have a friend coming over today to help me do a partial teardown of my peninsula. I'm going to rebuild it from an oversized 14 to 7 feet. Hey, Pete, in the future, reach out to me. I might be able to help you do things too on the weekends if you need it. But I'm your YouTube friend. You have real friends. Not that we're not real friends. You know what I mean. Okay. Kyle, I need some early Conrail models. And JP, a Dwight error needs its own acknowledgement term. A Dwight error. It's 99% operator error. Well, so often than not, it's our use of the technology that leads us to the trouble. And oh yeah, look, it's the wrong way because I got this. I got my logo shirt on. Great Northern. Oh, look, I can't point to the right because I didn't mirror it. I can't point to the right one. Here, over the right side. Great Northern JJ. Excellent work. If you ever need t-shirts or embroidery work with train stuff on it, go to Gelsman Graphics. And I did not get paid to say that. Okay, cool. Glad to help. And yes, it does. And I'm not having, other than, I've got the overhead camera here. It's not excluded from the background. And you can see up in that corner, far up there, you can see my green screen is not there. Because you can see that I had to run it. I'm running it at an angle. So now for those of you who didn't see it, this is kind of what the studio looks like in my game room. My game room has been taken over by trains as well. I can look that way. You can't see, and I've got a whole fleet of locomotives that I need to do speed matching on. but the train track is up right now at the moment. But I just decided to put this camera view on there. Oh, why not? I've got 2 cameras coming into this computer here. You can see the drink here. Rocky's hiding behind the other monitor. And Kevin Brown, he says, it seems to me that technology isn't always transparent and easy to use in the first place. This is the thing I struggle with at home and at work, because I'm one of those guys making this crazy stuff for you guys to use, and it's not always the best. For that, I apologize, being a software engineer myself. Must have took a week to set that all up. No, it actually takes only about a half an hour to set this whole place up. I agree with Kevin. That is why Tsunami is going Bluetooth programming. Haven't tried it yet. The only problem I can see with Bluetooth is just radio network interference, and how many other devices are competing on that spectrum. I have that. I've got wireless speakers throughout my house, and sometimes they work and sometimes they don't. All right, I think I put that up there already. Okay, we're 12 minutes in. We're not getting to the meat of the show, so let's start that off. And let's go over to desktop. No, where's that? Yep. Share the desktop. Share the desktop. And go talk about Proto Design Labs. So Proto Design Labs they're not, I don't know how new they are. So this guy, I know a small bit about his history. He used to work at Intel in Portland, actually, or Portland suburbs. And he's moved to Florida, and he's a model railroader. And he's also handy with electronics and electrical stuff, or electronics. And he decided there was a gap in how to put, let's see, and get this out of here. So here's our goal. And this is one that I did before, and this one's not working. I messed this up. But anyways, look, there's normally a wire coming out of here. Let me switch this back to main view. There's normally a wire coming out of here to control this turnout. This is a standard number 6 right turnout from Kato. And that's well and good. I've actually cut off the ends, and I put ferrules on here just because this is stranded wire. Makes that easier. I also cut these off because I don't want to drill a 1/2-inch hole in the plywood everywhere. And I just want to, and I don't particularly care for their connectors. Anyways, that's a side point. But I have areas in my layout where I might be using these, and I'm not going to be using these too much anymore. In fact, I'll be selling many of them that I have, because I accumulated way too many of them building my previous layouts. Let me jump back over to the chat. JP says it looks like the first offerings were in 2023. So yeah, so it was 2 years ago, and they have offerings for HO turnouts and number 4 and number 6 Kato N scale turnouts. So here's the instructions that come with this. Let's fairly good, but I'll tell you that you really need to go and look online. And let's follow that rabbit trail here. And go there. Yeah, and so from here, go over to products. I think I've got that. No, that's the downloads. Downloads. Oh, I did it again. Okay, downloads, and go down to installation guides, and this is the one we want here. The N scale decoder for Kato turnouts, and it just so happens I already downloaded that here, and we're going to go big here, present mode. So everybody can see that well. I can't read your comments while this is up, so you'll just have to bear with me. I hope that I'm nobody has this. So this is the that's too fast. So we've got the installation guide. There's a sample of both the number 6, which we're going to do, and the right and the left. So they're mirror images of each other. These are all the things they recommend that you have on hand to do this install. Should be fairly common. Oops, dropped my phone, which has the microphone attached to it. Okay, should be fairly common tools that you might have. Don't know why he's got scissors. Tin snips. Well, I didn't do that with scissors. I just did it with, let's see. I did it with some rail nippers. And I've got 2 sets of rail nippers. Oh, why did I use these ones? I should have used the non-rail ones. For those of you that sometimes grab the wrong rail nippers, don't use these to cut really hard wire because you'll notch them. The rail tends to be a little softer. Anyways, this is my good pair. My other pair that's notched, I put no rails on it, written on there. That's in the other room. Anyways, I'm digressing as I always do. So let's move. This is our goal. And the other thing you want to have is a way to do your test track. So I've got a little Kato. This is it's not the jumpers, but it's got, that snap-in thing. This just allows me quite easily. Our goal will be once I'll turn on the power from my command station, snap that in there. We'll have power, which now with no wires to this, the track power is what is going to power our decoder. So let's go in, and so we need Phillips head screwdriver, check. Long nose electric pliers, I've got that, check. Analog or digital multimeter, check. And a handheld bar magnet, insulated to not short the track. Well, I don't have this. This is just one of those ones that comes with a lot of. You probably can't see that, but I've got a magnet to go over there. It probably would be easier if I had a much larger magnet to do this, and then we'll go over why you need a magnet in a moment. So this is the underside. When we take off the cover to that turnout, and it comes off, there's 2 screws to take off, but this is the insides of what a Kato number 6 turnout looks like. So you've got this fiddly little straight wire spring here. It's fiddly because it has to go into this hole and it has to go into that hole. It's really can be a pain sometimes. You got the solenoid coil you've got this glue spot that they always have here. There's a piece of glue that's supposed to hold that down. Although I found that almost always, now I don't know if that's just to glue to the solenoid for something, or if that was supposed to glue that to the turnout and hold it in place. In any case, this solenoid here usually just lifts right out. You've got this black piece here, which is the actuator extension, which snaps into this called this main actuator, and that is the little piece that you're allowed to use your finger to change the turnout from what do you want to call it, straight to turnout to turned. I forget what the term is. JP's probably saying it right now in the chat. T-shaped frog. Okay, so this little piece is what controls on the number 6, powering the rails of the departing or the. So when you go, let's back up. When you go from the main line running here, this will actually be turned. So this T is moved over, and this little pad and this little pad get power, and thus this rail here will provide power to this part of the frog. So the whole reason is that, remember that it's a little bit different when you go and you're going from, I'll call this rail A and this rail B, and this is rail A and rail B. Well, this frog is oftentimes, depending on the setup, and it's not this way for Kato, they are actually insulated. So sometimes, though, you'll have turnouts where this rail and this rail actually might be powered together, and that causes what? That will cause a short, right? Because that's rail B and that's rail A. And that will cause a short if you're running DC or DCC. So this turnout right here is automatic power routing. That's what they call it. And this is even the setup. We'll get into it in a second. I'll show you once we open this up what we're dealing with here. There's a little socket here, and this is like a decoder socket. It allows a dwarf signal to be snapped into this turnout, and it fits right through this little, what they call the wire tunnel that was there to allow the wire to come out from underneath the turnout. Let's see. You've got the board. So this is for the left. We're looking at a picture of the left install. We'll be doing the mirror image, the right install. And the coil solder points 2. So these 2 points here on this side are the solder points for the coil. And then there's points here, 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 and here. We'll do soldering of the board to the brass connectors to the track. So the board itself does not directly connect to the track. What Kato does is it has these 4 little brass pieces that extend through the plastic that connect to the track, and then they sit underneath the board, and then they make contact with their board. And that's what we're going to do here to make sure that it's not just going to randomly turn off. We're going to solder those pieces together. So this is actually, those steps are what make this I would call it, it's drop in, but it's also going to be, there's no going back. So once they make these changes, it's not going to be easy to turn this back into the Kato switch that we had before. So this is the first instructions that we would do. I'm going to run through all these things so you know what steps we're going to do. Well, we first there you see there's the two screws that we're going to undo, and that allows us to lift this back metal piece off, and then that wire is coming through that hole, and there's that wire tunnel. This is what it looks like before we change anything. So the steel metal piece has been pulled to the side. Here's the two wires coming in that would go out normally to your switch, or it could go to, like I used before, a DS74 to power this. And so then you can see all the same parts are there, except this is a far simpler. This is a no-brain just board in here. So you can see here are the 4 tabs. Here is that T thing that's actually going from this is the power routing T, and it's hooked up to that actuator extension here. And then by moving the switch here, when you're turned over, that allows you to change it from thrown to, I guess, closed. Closed being go straight through, thrown being the diverging route. And right now, in this particular case, since it's going from here to here, and you can see down in here, if you can see my little pointer, down in here, that these are those brass pickups. So one is going to that rail, and this one here is going to this rail, and this one here is going to the outside rail. And there's another one that's kind of hidden underneath here that is actually connected to the rail that goes straight through, and it's not disconnected. So that rail is continuous. Let me take a moment here. I'm going to swap back over to the main view of the camera and catch up on the chat for a second and see. Who do we got that joined here? And let's see. We got what is number 1? I don't know what number 1 was. Be a right angle, right angle turnout. I did the same thing with my original rail nippers. Soldering pencil. What is number 1? Yes. Okay, that's what I'm talking about. Not what that is. My soldering pencil. And in my case, I've got this small little soldering pencil. I did have a Weller one. I didn't like that the temperature wasn't controllable. This one is. It's called a KSGER, something made in China, which will cost more going forward. It just heats right up, and it's fairly reliable. Also, the tips, I'm not going to do it right now, but tips pull out, and you can change them. And I just am using just this kind of flat tip. Let's see. Todd Armstrong says, I found out the hard way about snipping piano wire. Yes. I think I may have, although I stopped using that. I went because piano wire is really hard to snip. When I was doing my tortoise installs, you have to snip the piano wire when it comes up from underneath the layout and goes through the little crossbar. You need to snip it, otherwise your train is going to hit it, right? Because you can't have a tall little piece of piano wire sticking up. I switched to actual wire cutters. People have another name for them. Just in case you didn't know, throw wire for the slow motion turnouts. Yes, I know that one. Yep. I do have a lot of tortoise turnouts on my layout right now. And actually, well, there's some other choices, but I prefer those to control my Pico turnouts. Okay, with that said, let's get into the real meat of the show. I think, oh, wait, we're going to go back through and make sure that we are reading the instructions. So this show might go longer than than an hour. Maybe not. Okay, so that's what it looks like inside. I'm going to just spin through this. I've done 3 installs of this so far, so I should know what I'm doing. First thing up, after we do that, they say to take all this stuff out. I'm not going to take everything out. I'll tell you why when we get into it. But while this screw here is still attached, we're going to take our pliers and also potentially some tweezers and help bend these tabs, or they call them rail clips. These are attached to the end of that brass part here. So the reason why they want to do this is because you don't want to pop this off of here, or you probably just ruined your turnout, or you'll have to somehow reattach this. So bend those all up, and this also shows that we've desoldered both the turnout wires, so that red and black wire now desoldered, as well as the coil wires are both desoldered. So they come in this configuration for Kato, they come right to here. And that makes sense, right? Because you have the red and black wire going to hooked up directly to the coil, and on the switch, you reverse the polarity there. Or I think what does happen is I think the result of throwing that switch might actually throw the polarity of the coil. But that won't matter once we do the install here. So we're going to trim those off with our cutters, so they're flush or so with the board. And then we do the final piece of the lift out and uninstall. We undo that screw. We take out that original part of the board, which we won't need anymore. And there's all those clips that are there, and you can see where they're touching all those rails. Then the install here, you drop this in, and we'll screw this down here to hold it in place. Once we get it just centered, we're then going to go and solder to these 4 points here. Okay. I'm going to also then do another piece at this point, which is I will make sure that we are getting from this point to that rail. I will make sure that we are getting that those solder are good connections, and that we will use our multimeter to go and test the continuity there. So put it over onto resistant and actually make sure that we're getting good connection there. And that's where they show this here. Test the wires. Test to make sure we've got, so this rail here in the top from the diverging one actually yeah, this one actually shouldn't show that it's getting power because it doesn't have that T-bar in there yet. Then we can go and drop the solenoid back in. Take the shorter wire to J6, longer wire to J5. And this is showing that same thing for the right-hand turn. So this is actually what we're going to do. The shorter wire will go to J6 jumper, and the longer wire will go to J5. Got tweezers to hold that small little wire in place so you don't burn your fingers when you're heating that solder up on these little pieces here. And then test, and what you should see is about, they said, what, 2 ohms of resistance between this part. So this whole coil has got enough resistance in it because of the magnetic properties of it that you should see about 2 ohms of resistance between those 2 places now. And they didn't show it, but he's taking that screw out. Then we can put the screw back in, put this in place. Now, I might not do it this way. I'll show you. It's a little bit fiddly. You add the extension back in, install that spring. I'll tell you, I'm not going to do it this way. And then this is what we would use, the tin snips or that, to cut this off. And then we go on to the install of a DCC part. So let's pop out of here. Let's go back over to the comments and one last time before we really go into getting things going here. We are at 9:37, and so that's our mission. So let's see. So Steve 87, yeah, okay. Well, who do we got? We got Steve 87 has arrived. Closet Branch, if I haven't shown you, we got 14 people. Thumbs up. Yeah, give this a thumbs up if you're enjoying me ramble on about how to do this install. Lee at Anfield Road, layout in the loft. Welcome. And Dats, Closet Branch. Yeah, thanks for coming up. And JP, is this for wireless? We should say wireless is without wires, but it's not really without wires. It's track powered decoder. So like JP said, it's like the Wabbit. And Closet Branch says, so DCC command signal is going through on the rails. Yes, and it is that signal for which the decoder. So this is a stationary decoder. Think of it as this is a decoder that is always on that track, but it gets its a command to basically turn it to thrown or closed from DCC from the rails. So it's picking it up right from the rails. It's not going by some other mechanism. It's not going over some other wires to get there. Okay, so with all that said, we're going to switch over to overhead view, and let's get going with this. So the first thing is you're taking out these little screws. Put those in a place you won't lose them. Sometimes you might have a little case or something there. So that's all there is to taking those screws out. And then this will, let's see, sometimes this can be, just reach your fingernail under there, and this is bent in there, and boom. That's all there is to taking that out of there. So, and so here we've got the coil here, and look, the wire, that thing is on the other side. There's the glue spot. Here's that piece right here, the actuator, and that's that mechanism. So you can see the little tab on the other side. Bring out another switch. You can see that's this right here. Manual control. You're not going to lose manual control of the turnouts, which is actually kind of cool. So we got that out of there. So the next step was they recommended starting dismantling things. So we're going to start that. Actually, I'm going to leave that screw in there. I turn on my soldering iron, and it should be heat up and quite fast. I've got my piece there to remove clean off the soldering tip. I don't have a tinning thing. My tip is actually usually pretty clean. There you go. It's shiny. And I've got some lead-free solder here, which usually does the trick. So it's already heated up, as you can see. So you can see a little bit of wispy smoke that I should have had my little fan here that sucks all the smoke away, but I don't. So is this a standard turnout or already power turnout? So this is a standard Kato turnout, Steve 87. This is a standard setup for a Kato turnout. I've done nothing to this before. This is what you would see for Kato in N scale. And I think you'll see something similar in HO if you were going to use Kato track. Now, not everybody is going to use Kato track, but for those that are, hey, here's the install. So here's what we're going to do. We're going to go and we're going to touch. We're going to try not to burn our fingers. We're going to touch that solder, get it heated up and take that off, and do the same thing here with the red wire. So there you go. Bob's your uncle. We are now wire free. We're done, right? Oh, we're just getting started. Okay, so this is that back plate that keeps that there. And you've got the black wire and the red wire that goes into the standard Kato plug. Usually they've got that plastic piece on there, but I took mine off. And it's the same connector they use for their power. So JP asks, does the decoder give you positive feedback as to the status on DCC? Great question. I don't know the answer to that. I haven't had this hooked up to running to the system where I have the computer hooked up to tell you. My hope would be that it would do that, but I don't know the answer to your question. So let's see that. I almost messed up the screws. Okay, so we've got part of those off there, but let me take these other ones off of here. And this is going to be a little bit more tricky. Oh, one is already detached. Oh, they're both detached. So I'm going to take those small little wires, put the soldering iron down so I don't burn myself, and I'm moving those out of the way. Now, these are insulated, standard either motor windings or solenoid windings. You know that solenoid operates on the same principles as motors do. And so then we're going to take, now those are detached. I'm going to take this off of here. Okay. Just put my finger on the main actuator. Got that other little screw there. Take this little T-bar off of here, and that just pivots and then comes off of there. And then this little piece here, let's see which way does it go. It comes off. That way. So lifts from the outside out. So I'm going out on a limb, even though, okay, we've seen already what's happened here. Down here, this is this spring. This controls the points and allows this to be locked in place. It's already out of this hole, which we'll need to put this back in here later. Why don't we'll go full fiddly here, just for sake of following the instructions. I just took the whole thing out. All right, so you got the actuator bar out. I am going to leave that spring is still going through. There's a center hole here that allows it to pivot. I'm going to leave that there. And then there are, I believe there's two pieces of metal here and here, which the solenoid uses to pull that one way or the other. We'll lift out to the solenoid. And you can't really see this. These wires are so fine. But there's the long wire here that's collected near this glue spot, and here's the short wire. And welcome, Andy in the UK. And now, the next part of the instructions were, we're going to take this board and we're going to hold this in place with that screw. Why, you might ask? Well, we're about to do something, and I'm going to turn off my soldering iron because I don't need it for the moment. And so this next part involves lifting these wire, they call them wire clips. You can actually, you don't need to have, but you can bend those with your needle nose pliers. But I like to get under that little part, so get it start bending with just sliding these pliers under here. So once we get them, we want them pointing straight up. And I'll show this closer to the camera once I think I've got that. So we've got those all pointed straight up. If we looked at the instructions, that's very similar to what they did. Now, this step is, so I do have some of these other cutting things. I use these are not strong enough to actually cut through that brass, but they will make a little like kink in it, which will make using the Xuron cutters a little easier. At least that's what I've found. So I'm just making a kind of a crease in that metal. Or if you had super strong hands, you probably could just do it. But I'm weak. I'm a weak person. All right, so now I'm going to put my finger on part of that tab so it just doesn't go flying off into the room somewhere. And the satisfying click of cut metal. So that is cut almost flush. It doesn't have to be completely perfect. What you're trying to avoid here is that you don't want that long enough that it will touch that shield once that shield is back in place. So I found with the Xuron cutters, their sweet spot for cutting is not at the tip. It's more in the middle to the last part. So there's that one. That was actually easy. The reason why I can't really get in here is because there's some plastic. There's some plastic parts here. They're actually holding this board in place so it doesn't shift. That does make it a little bit tricky to get all the way in here. Remember, we don't want to manhandle this because those little brass pieces will be damaged. There we go. I didn't get enough of that cut off. There we go. Much better. Okay. So we got all the little brass pieces there. We got these two screws. We got these parts. And now we are at the next step. I'm ready to remove the screw and take this board out of here. We don't need this anymore. And we've almost rendered this useless to us in the future. That's the little circuit board there. Now that this is out, it's easier to see how this is power routing. This lead, this jumper here connects to that center screw, which kind of grounds it. That center screw, I don't know what part of the turnout it might be connected to. Actually, there's a hole there. Does that even go through there? Should. So then these are the 4 pads here that this T bar, this piece right here, pick that up. When it's screwed in place, it would make a connection to there or make a connection to there. So that's your power routing and how it reverses its polarity. So then it even has part number 2051R. Tells you that this goes in the right-hand turnout. And now we've got our little naked clips here. So now we're to the next part. Here I've got in this non-static conducting bag, which are to keep them from going bad in transit. Oh, and I see something else that they've done here. He's put a little circle of that Kapton. He's got a circle of Kapton tape, which I have some more of these left over from the other part right here. Maybe you've seen there's some shorts there that could happen to the board. So how did this go in? So this lays back in here that aligns with where those clips are in that same slot. Kind of like that. And each one of those clips should go through its respective area. And I see that they are. I don't think you might not be able to see that. But let me put the next step is to put the screw back in the hole. So we take this screw on and off about 3 or 4 times during the install. So what do we have here now? So we've got that socket here for the dwarf signal connector. Let me show you one of those. There it is, and it's got LEDs on both sides. So when it's closed, it's green, and when it's thrown, it's red. Pretty good for if you've got the room on your layout. And let's see. So what do we need to do next? So this will not work unless we get this thing connected back in. So what I'm going to do is make sure that I'm looking at the instructions over on this other monitor here. And I'm looking at the coil wire. Okay, so this is for the 6. All right, so I've got that. And it says, there's the glue spot. And it's saying, this is a long wire. And this is a short wire. It's coming off kind of like the other way there. The short wire is at the end here. The long wire is here. Oh, I know what the glue spot is for. glue spot there is make sure that your windings don't unwind. Okay, so we need to put that between these two plastic pieces on either side of here. Now, the short wire goes to this jumper here, which I can barely read, but I believe it says it is J6, and there's J5 there. So these correspond to those two spots on the original board. Did I focus? Yeah. All right. Hopefully we've got this. So short wire goes to J6. So it's right little here. Wait for my soldering iron to hook up. And at the real end of that wire, not even going to be able to see it, is the part of the wire that does not have it does not have any insulation on it. So even though these look like they're bare wires, they cannot be bare. Otherwise, this whole thing would be, the whole coil would be shorted together. There'd be no point to it. All right, so we're up there running again with the solder, and we have to use the little tweezers here. And I'm going to just come in here, trying to keep this so you can see it with the camera. Sorry, it's not close up. And heat that up. Touch it and put that wire in place. Nope, I didn't get it. Okay, nope, I still didn't get it. This part where it can be a little bit fiddly. Yes, it's there now. Okay, so lay that wire a little bit flat. We'll get these wires arranged before we put the case back on. Hopefully I don't burn my head when I... Okay, so this long one, this is the part where it gets, okay, so we got that one there, ready to touch this on here. And that is also connected now. And now that we got that all there, I recall that that's not the exact sequence of doing this install, right? I got ahead of myself. But what we need to do is we need to have solder in each one of these 4 holes here. You can see that per the instructions. So there's these points 1, 2, 3, 4. So we do need to actually use our own solder. Let me move the tools out of the way because we don't need them anymore. So what I'm going to do is heat up this pad and put some solder hopefully down there, and it will go in there. Now it's on there. And what you want to have is it should be a little dimple there. So I'm going to do each one of these, and we're going to come back and test and make sure that from this pad to the respective rails that we've got connectivity. And I will catch up with the chat here in a moment, because there's some reasons why this might not connect to that tab. So make sure I'm pushing down on the board. Make sure that it's connected to the tab. Might not be, so we're going to test these before we close this all up. Make sure that it's working. And that one think that's okay. Okay. And the last one. Last one. See, I think that's okay. So, I'm gonna reach around here, get my really basic multimeter. Gonna turn that. This does not have a tone, just a cheap one. And to make sure to test, okay, we are getting continuity there. Move some of this stuff out of the way. Okay, now we're gonna go from, you can hit the rail through this plastic here. This should touch here. So I'm gonna go to that little pad here. And we're getting good reading there. And this rail comes to this pad. Getting a good reading, very little resistance. And this one goes to the outer rail here. Also good reading. Just lightly touching that pad, so I'm not. So if it wasn't attached by pressing down, I would make it kind of have connectivity. I don't want that. I want it to be connected. And there we go. And we also see that between these two pads, there's no connectivity, no resistance, I mean, infinite resistance, open circuit there and there. Okay. We've got that part done. I'm going to turn off the soldering iron. Now, let me see. Where did I put the tweezers? Here. And where are we at time check? Oh, we're at 10 o'clock already. Well, I have underestimated how much time I should be talking. And there was a little bit of solder there. These are insulated. So we want them to be kind of inside of this stuff and out of the way of the plastic pieces. And really not touching the board if we can avoid it. But I don't think it'll cause too many problems. It'll be nice if it's not going over the board. So that one's tucked under. I know you probably can't see that. These are really fine wires, right? Okay, so now we've got that set up there. We tested out that part of it. I am going to do this next step here. So this actuator goes like this. It has to go through the turnout throw bar on this end and into this small little hole there. And that completes its ability to be springy. What I found is easier to make sure that you're through this hole at the end here first. And for everybody who's still out there watching this, thank you for watching. And thank you for liking and subscribing as well. And so that will sit like that. I don't have it in this hole yet. We will get to that in a moment. And the reasons will be a little bit obvious because it tends to just jump out of that hole. If you look at this wire piece here, this little dimple that's right there, that sits right over that hole, and that makes sure that that holds that wire in place and it can't jump out. Okay. So, might as well just do this little modification now. The reason why they say to use wire snips or tin snips is because, or scissors, is because also these Zuran cutters don't have the length. But what I found is like you can just do it like that. So I cut 2 ends off the side. There's that channel there. This piece. Don't need that no more. Now that's the back. That's set up. This will lay back down in here like this. And the reason why we cut this off is so that we give ourselves 2 reasons. One, there is an LED light down in here on the board that will turn green when we go to do the programming of this. And sorry, we're going long. This is going to be a longer one than usual. Okay. So what's the next thing that we want to do? Well, we've got to get this brass piece back on here so that it will pivot. The screw is in the center, and then the other part hooks up to, let's see if I get this right. I'll get this staged here. So once it's turned, it can't come off of there. It looks like that kind of. Looks like that. Now this, when I take the screw off of here, it's all held in place, so it's not going to be really moving around right now. So to do this, great, just drop that on the floor. All right, we'll get it in a second. We have to, this just slides back. You lift it up, and it's got a little finger that slides back into a hole. You would see this if you were doing this yourself. I apologize. I gotta pick this piece up. It wouldn't be a show unless you drop something on the floor. Okay, so I'm going to put this in straight, and then you can turn it that way. And now it's all there. And that screw, the magnetic part of the screwdriver will stay there. Gonna make sure that we're got this, and you don't need to tighten that too much. It'll just hold that in place. So there you go with that part. There's only one last thing to do here. This spring needs to go into that small little hole, and this can be, I think, sometimes the most challenging part of messing with Kato turnouts. If you don't get it right, and if you pull it out, which I've almost done, if you pull it out of the hole on the other end, you're going to have trouble. I'm sure there's a great way to make sure that you do this, but I have not discovered it yet. Now it's over there. Bear with me as I try to put that back in the hole. Come on, you little demon. Oh, no. No. Out of that hole. Okay. You guys can all be laughing at me in the chat. There you go. Come on, get it there. Go in that hole. No. Yeah, this is the most fiddly part. And maybe a different type of tweezers would be helpful here, but these are the ones that I have, and they worked before. Just gonna get that into that hole. No. Yeah, this often feels like if you watch Dave's DB Tech shows on repair of stuff, things that happen in here. Come on. Okay, lift that up. Yes. We have touchdown. We are on the moon now. Okay. It is now, I'm not going to lift it up because it might pop out of there. That part of the spring is in there. That part is through the throw bar over here. And these parts are in place. I am going to do one last check before we seal this up. I want to make sure that we are getting the power routing feature of this. And actually now a good chance to see catch up back on the chat. Yes, we were laughing. Yeah. Not too, what's it? Not too picking, but the bill of your cap blocks the view when you lean forward. Oh, that is it. Oh, there you go. I will have to remember that in the future. Sorry about that. Sorry about that. Okay, so we're going to go and make sure that this rail from here will route through here, and so it should get to here. And it does. And this rail here should not be going to here, which it is. Is that right? We're switch to diverging route right now. Okay. Yeah. Let's go. This rail here, follow it. It should go to that rail, and it does. And this one is the outside rail. There's no, that one goes. And of course, this one goes. And what we shouldn't see is this rail here should have no connectivity to here, although it does. It's probably from the points. What is going on there? Very interesting. Would that cause a short? No. So it should be there. What we shouldn't see is nothing for the opposite rails. Yeah. So there is going to go to here, but not to here. Yep. And obviously this is the outside rail will go here. And test this out too. This would be a bad thing. Oh, sorry. If we got these 2 points. All right. Sorry you couldn't see all that. I think my hands were blocking the view. But it's hard to watch what I'm doing and watch the view on the camera at the same time. Now take down the flag so we can see. Where's the flag? Now take down the flag so we can see. All right. The last thing I'm going to do, because I don't want that spring popping out of here, is I'm going to put this back in place. Oh, sorry, the chat. Got it. Okay. We're going to attach this temporarily. Now we're ready to get close to the end of the physical install. And I don't know if I'm going to go into the programming of this. Oh, what's a few more minutes? What's a few more minutes? Probably running into somebody else's show that started at 10 o'clock my time. I apologize for running long here. But I wanted to make sure that we went through the instructions, because I think that's the most important part about this install is go and read the online instructions. So we cut the plate. I will show you in a moment, Steve 87. Steve 87. We cut the plate. Why isn't this being magnetic? We cut the plate because there's a socket that is there, and also because it exposes what you'll see in a minute. There's a green LED here that lets us know when we put a magnet close to it, it uses the, what is it called? The field effect. Go in programming. on the main and service mode. Okay. Here we go. It uses there's a scientific name for that field effect, but the board has something that senses that there's a magnet close to it, and when it gets close to it, it allows that to be programmable manually. So we've got this all in place. We'll flip it over, and we'll do one last check here. Hopefully I can not put my fingers in the way. Oh, just before I go, here is at least one of these dwarf signals. The reason why we did that is because it will, if I left myself enough room, and I think I probably should have cut a little bit more of that off there, but I think that's in place. So it mounts like that. And this will work for 49 millimeter separation, but it won't work for the dual track 33. It runs in, it's too close to the ballast of the other tracks. So I'm not using these. But that snaps into that socket down there. And actually, he says in the instructions that you can just feel under there. I'm going to do one other thing here. I don't like how that is not cut as cleanly as I wanted it to be. Hopefully we don't let that spring loose. Spring is still in the hole. So I need to try to clean this up a little bit. I'll just cut a little bit more of this off of here. Of course, I didn't get it straight. Yeah, so I'm trying to make sure I've got room for that socket to cleanly go in there, if I choose to put it in there. And I cut farther into the shield. That's okay. Nobody will know because it's sitting underneath the track. Okay, so now with that there's a lot more room here for that plastic piece to easily snap down. Before I do that, I want to make sure. Yep. Still appears to be working. Get a big file. Yeah. Don't have a big file. A small file would work, actually. All right, we'll just put that there with our fingers. Always good to reverse that screw first to make sure that you've seated it properly. Now, with that in place, that socket can easily snap down in there. It comes out on the side of the roadbed here. And there it is. So this might be the one that I messed up. I'll put that over there. So, okay. Let's put some tools out of the way. Don't need the multimeter. Don't need the multimeter anymore. Let's keep it in that configuration there. I will reach over the top of things. I'm going to plug in my command station. You hear the beep. And move some other things out of the way. Apologize for getting in the way. You can see here is my Digitrax command controller. And if I look, you can't see. Actually, I can show you. We do have We do have power on those rails now. 12.6, 12.7 volts, which is normal. So what I do is I take this, connect it right to there. Now, what we should see, power should be just the same as normal. So we got power there. And we do have power here. Nice. So let's go that route. We got power there. Yeah, I got power there. So already a slight improvement with just putting this board in place. It's routing power through even when switch isn't thrown. So let's see. This is the moment of truth. These are programmed at switch 1. So thrown. There. It's alive. It is alive. That's awesome. We have achieved success. We did not smoke it. Now, programming this. Let's turn it over. And I'm going to say, call this switch. I don't know which one to call it. We'll just say 56. So I typed in 56 on my turnout control. And my magnet. And let's see if I can do this. Sometimes, there we go. Can you see? You can't see that. My hands are in the way. The layout, the light is on there. So when that is on, we can hit we can program it. So now, voila, the magic of that. Now, I don't know, it says you can program this on the main. And right now it's closed, thrown, closed, and we're using address 56 right now, and not the ones. And so we have achieved success. We can disconnect this from the power. One last thing before we do that. Let's see. I think that's the wrong one. I have another one. Where is the little guy? Where is it? I know I have 2 of these dwarf signals. Here it is. Now, let's disconnect this from the power. And you can do this by just sliding under, in theory, and just getting that connected like that. So in theory, what this should do, oh, will you look at that? Can you see that? It's green. And it's red now. Green, red, green, red. And it's correct too, which means I got the solenoid correctly done. So there you go. And this isn't a requirement. The dwarf signals are not a requirement for this. Not a requirement at all. And so there you go. If I wasn't showing you guys how to do this, I think if you'd done more than one of these, you would be done in about a half an hour or less, including all the testing and whatnot. So let me switch up the view back to the main view here. So there you have it. That was the install. I know we ended up running along here, but we took about 20 minutes or more to go through the instructions. Not in complete detail. I have gone through them in details. I said, if you are somebody who wants to use a remote, say, look, what do we end up at the end? Other than this looks a little sloppy there. The tin snips, I could have cut that right off, and I will consider that on my next install. Because I'm actually going to order a few more of these. I'm going to put this in a point in the staging yard where it's farther in and it's not as easy to see, and also I can get at them. I do need to find out if that is true, that you can do reprogram these on the main without that. And I don't know. Let's see, it would be up here. Well, you can't see that. I do need to figure out if you could actually reprogram these on the main and how you might do that while it's connected to the track power. Not sure. Would be nice to have. I know that one of the reasons that would be really nice is, imagine that you want to renumber your turnouts. The last thing you want to do is like have to pull your track up and do that. But it might be possible with a larger magnet to set it across this area here, so you can see where the dwarf turnout, or on each sides of this, there are little cutouts for where the wires would come out. So it's that wire tunnel, they called that before. It might be possible to put a larger magnet that's insulated. That's why they said insulated, to rest that on the top here and reprogram that. I'll have to try that later. I bet it works. Hall effect. That was the thing I was thinking about. So that's a physics term. Anyways, here we go. An hour and a half show. It's a new record, and I spun my hat around. Sorry about leaning in. I'll have to keep that in mind on the next show. I'll probably watch this again and be laughing. Well, you idiot, you blocked the view. People couldn't see what you're talking about. Use the magnet from the top explains why they wanted the magnet to be insulated. Yes, because you need live power in order to program it. So you would be a short. New record time for cake. All right. Well, you know what? That sums up this show. What do we got next week? Well, next week, because today's the 1st of February, what does that mean? Well, layout photos of the month are coming up in the next show. So that will be the show. Everybody's layout photos from January 2025. The first show of the 2025 will be next with these this year. So you can use, for example, NJ International, Atlas, Tomar signals. I don't know. Now, it's interesting. He has a few other, there's something that says J7 over here. And there's 6 little pads, and they're really tiny. I don't know what those are for. But the only thing that Proto Design Labs has right now that attaches into this is this little dwarf signal. But it would be nice, and I mentioned to him that if this didn't have such a big footprint, it could fit on the 33-inch or 33 millimeter. It could fit on a 33 millimeter track distance between the two. Thank you, Ricky. Thank you, Lee. Yeah, I think you would, and you would have to know, and it's not provided with the instructions that I see exactly what the layout of this socket to this part right here. There seems like there's 8 little solder points here. But I'll tell you what, the guy, here's his business card. He includes this thing, James Burke, down in Florida, Proto Design Labs. It's a good product. Serves a good need for people that have like, okay, I can't get wires to this place. What am I going to do? Or even for that, hey, think if you were just going to take track out and set it up somewhere, and boom, if you got DCC set up, uh, it's already self-contained. And for fun, if you don't have another main line running next to this track, um, you got lights, and people like lights and when they change. And those of us who want to know just by looking at something, hey, which way is that turnout thrown? That's another good thing. So great little thing. I like this better than the Digitrack solution, which is they do have a decoder. I went over this in the past, and I actually have previously had two turnouts that I used the Digitrack small little decoder. But you have all these wires. They look like a stationary decoder. You have 4 wires coming out, and um, you put 2 wires to the track wire and 2 wires to control the solenoid. It's a little bit. It's not as straightforward as involved as it's not as straightforward as this, and the instructions are nowhere near as detailed as even this pamphlet. But if you go over to his website, you'll see that right now he's running a deal on these things. If you can call it that. Well, it's circuitry. It's not going to be cheap, but it's $20 a piece instead of 25 for the decoder. And also, I think there's a break if you get them in more than one. So if you have a number of turnouts, you can do it. But all of us know in the DCC world, nothing is cheap. I mean, another non-sound decoder to drop into your locomotives is easily $30 or $40. But this does put an additional cost per turnout if you want that control. But maybe you can be strategic about it. You don't need to have these on every turnout on your layout unless you want them. But I found that there was a lot of, if you're going to use Kato turnouts, and you're going to run the wires. You've got the DS74 you got to have hooked up. You got to have wires going to those. You got to have power going to your DS74. And over time, wow, how many of those? Each DS74 is probably about 70, $80. So it's about the same. About the same. It's just there's some other features there. We'll do some other investigations. I have 2 of these, not this one, but I have 2 on my layout right now that control whether or not I'm going and coming around the helix at staging level or whether I'm going up the helix. I've decided to drop those in there. Working just fine. The one thing that you won't get, which is you won't get the visual feedback when you're programming this of a green light unless you can get down and maybe when that on there, the green light can be visible through that wire tunnel when it's flat, maybe. Something to be investigated. I don't think we need to go into in this show. Thanks everybody for hanging in there and watching me through 90 some plus minutes of mayhem. And Great Northern JJ. I put the, I can't put it. There we go. I've got the opposite camera going on. I'm Great Northern JJ. There's all the Great Northern logos. Gelsma graphics. Do these great embroidery shirts, hats. Not this one. I've got a hat coming somewhere, and I've got a hoodie. But I'll tell you what, that hoodie, that Port Authority hoodie, that is actually too warm to wear. So that's why I'm wearing, I got a long sleeve. Yeah. Nike stuff. For those of you who don't know, I do work for the big swoosh. And, oh yeah, so what Rocky says, don't forget me. Oh, me. Yeah. Okay. So Rocky says, what do we say? Yep. We said, thanks for watching, like and subscribe, and I'll be back next week. Cheers to you.